What is welding? I'm putting this video together as a very basic explanation of what welding is. I feel like most people understand when they hear the term welding, it has something to do with metal and something to do with heat. And at the heart of it, that's all it is. We are controlling a heat source to put two pieces of metal together. From the first crude welds made by heating metal up and then pounding it together to the laser welding that we have today, putting together electrical components and sending spaceships up into space. It's all about sticking metal together using heat. For our purposes, there are really only a few kinds that you need to be familiar with that I'm run across in industry or any fab shop that I've worked at, or like a home garage or a career and tech ed educational type setting, and that is stick, MIG, TIG, and oxy-fuel. There are many names for all of these processes. Again, for the purposes of this video, I am simply doing the most common names used so that the layman can understand what is going on behind those terms when they hear them in conversation. Like, oh yeah, I've heard that. I've got an idea of how that works. Again, I repeat, this is as little information as I felt comfortable giving while giving a comprehensive overview of the most basic processes without subjecting the viewers to overwhelm. This is for the grandparents who want to understand more about what their grandkid is getting into when they're going into school for this or starting it as a hobby, or for people on the internet who just want to know more about what the heck is going on in here. What the heck are we doing here? First of all, for the purposes of this video, welding is using a heat source to melt the edges of two pieces of metal together to form one homogeneous piece so that there's not much of a joint there anymore. Rarely can we do this with heat alone. We usually have to add additional filler material, like a stick of filler metal that closely resembles this base metal. While heat is important, it's the control of the heat that's most critical. Not enough and you don't melt that base material and you don't get it fused and it's not very strong, and if you put too much heat into it, you start affecting it at the molecular level, you start losing all the good properties of the material and it's changed irreparably. Ruined. Isn't strong anymore. The little area of molten metal where the heat is concentrated is called the puddle. We protect the puddle at all costs. Oxy-fuel welding is the most primitive form of welding besides heating metal up with coal in a forge. It uses a combustible fuel gas and oxygen to support it and make it hotter. No electricity, it's just these two tanks standing alone, mixing in the torch, and doing the work. My fuel gas here is acetylene, so I tend to call this oxyacetylene welding, though you can use other flammable gases like propane, propylene, MAP gas, and natural gas. The point is, it's a burny gas made even more burny by a supporting oxygen to melt metal. Again, no electricity involved. In the event of a grid-destroying doomsday scenario, you'll be able to make welds as long as you got gas in your tanks. The fuel gas makes the flame. The oxygen supports the combustion to stabilize it and make it hotter. Oftentimes this is used to melt two pieces of metal together, but actually more common, it's usually used to preheat material before you go ahead and arc weld it, or to bend material, or to deliberately distort material, or to move it into a certain place. You can move things with heat. Really move big things just by putting like a wedge heat on them. Or to braze materials together, which is basically melting a mix of like tin, lead, silver, solder into a liquid form, and it sucks down into a joint without melting the base material and is essentially a high temperature like super glue. That's what sweating pipes is. If you put a pipe over another pipe and put a little solder in there, that's sweating pipes is brazing, basically. And although there is no UV radiation produced with this process, well, basically no UV radiation produced with this process, you still need to use basically industry grade sunglasses because you shouldn't be staring at tactical flashlights either. It's bad for your eyeballs. Now I'm going to talk about the three common arc welding processes. Arc welding meaning you use electricity for this. That's MIG, TIG, and stick. That was oxy-fuel welding. That standalone is basically a glorified lighter. You're using a flame to weld. Very versatile. You could drag it out into a field and repair something. Got its limitations, but it's definitely got its benefits, and every shop should have one. On to arc welding. A lot of the times the old timers will still call stick welding arc welding. They think that stick welding is the only type of arc welding. Arc means electricity. Just like every other form of electrons jumping over a gap, like lightning jumping from the sky onto the ground or severing a cable, we use the heat generated by electrons crossing across a gap to melt steel. If you've ever jumped a vehicle's battery and you stuck the other cable on the terminal and you see that little spark, congratulations, you've just seen a very mild version of welding. Process on a very weak scale. The bright arcing, sparking part of welding that you see in pictures and on videos where the work is being performed is the work lead, but what you don't often see is that there is a second cable coming out of the welder, that is your ground clamp, is basically completing a circuit. The electrons are traveling from one pole in the machine to the other through the circuit of you welding to complete the circuit, just like in a simple circuit. Again, a filler material is added to the metal on the job in front of you to reinforce the joint. We don't just melt the metal, we have to add a little bit of filler material in there too. And it's because of this electrical arc that produces wicked UV radiation that you'll need a welding hood to protect your eyes and face while you do the work. And they come in these fixed shade lenses or auto dimming flavors. Since the heat it creates is by an electric current, the base metal melts immediately, rather than gradually with gas welding. The immediate location of the arc weld being performed is immediately hotter, much hotter than traditional gas welding. Because of this, arc welding also requires a shielding gas over top of that molten puddle. Molten metal has a ravenous chemical appetite for elements in the air. At these high temperatures, certain elements are drawn out of the air and mixed into the weld to make weak spots. TIG and MIG use a shielding gas that pours out over the molten weld as the work is being performed. Stick uses a flux that burns off. I'll get back to this. Shielding gas is non-reactive and it forms a little protective cloud around the puddle that displaces air so that impurities can't be pulled in. MIG welding is a spool of filler wire that comes out of the lead and is fed into the weld pool, becoming a part of the weld. When the trigger on the gun is pressed, three things happen. The wire feeds, the wire is energized, and the shielding gas is forced out to accompany the wire as it melts and feeds into the puddle. Not energized. You can see the longer it stick out, the more resistance there is in the wire. It's basically like an incandescent light bulb filament. TIG welding features a non-consumable electrode made out of tungsten, which has a very high melting point. The tungsten is ground to a point and then usually energized with a foot pedal rheostat, much like a sewing machine, and you can control the amperage in a infinite way. This is the fine adjustment. Set your maximum amperage on the panel, and so if I floor this, that's the most amperage I will get out until I go and adjust it there. Or sometimes you can get these with a finger slider, and some people use a toggle, like an on-off or a scratch start. Getting ahead of myself. The arc is clean and precise and very strong, and the rheostat allows you to add more or less heat depending on the situation or the material or the fit up. Torch is held and operated by your strong hand, and your weaker hand, your other hand, your off hand holds the filler material and adds as you go along, much like the oxy-fuel. This is an arc welding process where you use electricity to do this. Oxyacetylene welding, you're using a flame. The only way you can dial back on the heat when you're oxy-fuel welding is to physically pull the torch away. You can't do that when you're TIG welding because you have your inert gas, argon, coming through as you're energizing the tungsten. So if you try to pull it away from your workpiece, you're also losing your shielding gas and all the contaminants can get into your molten puddle. Again, what is not always clearly shown in videos and pictures is that this is one half of the process. There are two poles, a positive and a negative, on the machine, and you're completing a circuit because of this ground clamp. This is attached to the plus over there, this is attached to the minus over there, and the electrons are traveling in a loop, and they can reach this metal because the metal is touching the table that conducts electricity, which is touching the ground clamp that connects electricity. If I were to put my bare hand on this table and this on my tongue, I would now have put myself in the direct path of the circuit, and I would probably get hurt. But as long as the electrons are jumping from point A to point B, I'm not in a whole lot of danger by putting my hand on the table here. Path of least resistance. Stick welding is the original arc welding, so a lot of old-timers still refer to this only as arc welding, although, as I have already shown you, two other arc welding processes because they use an electrical arc to weld. A lot of people still call this arc welding. Just let them. It's stick welding because we are using a stick as filler material as also the electrode. Go back to my example of jump starting the car. One lead of the stick welder is clamped to my table or the workpiece, and the other lead is clamped onto this stick with a metal middle. The center middle metal part of this electrode is the filler material that melts and becomes a part of the weld. This crumbly stuff that's pressed onto the outside is a flux. The center is the metal filler material. This outside, this flux that's on the outside is non-conductive and it's pressed on, it crumbles off. It serves a bunch of different purposes, but the big takeaway is that it protects the molten puddle much like the shielding gas does in the other processes, because this is all you have. MIG and TIG have a shielding gas that pour over the weld as you go along. The stick uses flux. It burns off into a little protective cloud that displaces air from around the molten puddle. It also mixes around with the weld and floats to the top and solidifies on the top as a hard slag that protects the weld for a little bit after you've welded, so there is a slower cooling rate, and it doesn't have a chance to pull impurities from the air. It also kind of acts as a little bit of a mold to hold your weld in shape as it cools. With some stick rods. But sometimes that slag can roll up underneath your weld while you're performing a weld and make an inclusion, and that's a weak spot. Stick welding is smoky and sparky and strong and responsible for much of our infrastructure, our bridges, our shipyards, our rail yards, our buildings. It's our good old standby that's fairly easy to learn, fairly low startup costs, low operation costs, and can be performed on most steels and many other metals. The information I've chose to include in this video comes from many conversations I've had with new and novice welders and people trying to understand the trade, and so I may have omitted a few things here and there, but this video really covers the range of questions that I get most frequently. So these are the four main welding processes that you'll probably run into in a trade school setting or like an ag mechanics program or most fabrication shops, at least the ones that I've been in. The very big difference is that one requires a flammable gas to perform the work and the others require electricity. Gas welding is chemistry, arc welding is completing a circuit. Both are heat in service of fusion.